Well, hello everyone, and welcome to EdTech Tuesdays with ATEMs and friends. And today it's about making math matter in the K-5 classroom. Thank you all for joining us today. Can everyone hear me? Give me at least one thumbs up, or I can hear you. Unmute, put it in the chat. Let me see. There it is. Okay, you can hear me. Excellent. My name is Pernell Allen. I'm the Alabama Technology and Motion Specialist located at the University of Alabama at Birmingham. UAB, go Blazers. Those universities you see over to the left are where other ATEM specialists in the regional in-service centers are located across the state. That's my contact information. Both emails I do respond to. Also, if you're on Twitter, X, Twix, whatever you like to call it, I am at UAB underscore ATEM. If you like this session or any session provided by ATEM, please use the hashtag ATEMPD on any and all social media platforms. Region 5 serves the following LEAs. That's Alabama Aerospace and Aviation, Bessemer, Birmingham, Empower Community, Freedom Academy, Fairfield, I3 Academy, Jefferson County, Leeds, Legacy Prep, Magic City Acceptance Academy, Midfield, Tarrant, and Trustfield City Schools. After today, we only have one EdTech Tuesday session remaining, and that is, may I teach you about engaging technology tools and strategies, which will be led by my colleague, Carol Foster, who's at Auburn University. And if you haven't had an opportunity to listen to our podcast, which is Tim Talks, that is a series hosted by my colleague Angela Clark and myself, where we explore exciting developments happening around schools across the state. We also aim to raise awareness about ATEM and other state initiatives, highlighting the valuable services and resources that we can provide. Our latest two episodes include episode 12, which was the Library of Innovation with Tamara Clark, and episode 13, Failing Forward, with Dr. Joseph Garner, who is the Office of School Improvement Coordinator. You can listen to Tim Talks on Spotify, Amazon, and Apple Podcasts. And very important note right here, you all, if you have not had an opportunity, and even if you have had the opportunity, we would like for you to join us with our Alabama Educational Technology Conference hosted in Mobile from the 16th through the 20th. This is our EdTech conference where we speak about everything, exploring sessions on power school, artificial intelligence, podcasting, robotics, and you get to experience firsthand some of those latest advancements in educational technology. So we definitely hope to see you there, with this year's theme being Building Digital Bridges. At this time, and without any further ado, I would like to turn it over to our guest speaker, Alicia, who would bring to you Make Math Matter in the K-5 classroom. Alicia, I'm going to stop sharing and turn it over to you.
All right, thank you. I like that Twix, by the way. I hadn't heard it referred to as that yet. That's a
Yeah,
new one.
put a
Cute.
spin on.
Yeah, I love it. So some of you may know me. I've presented at a couple of these webinars for you guys now, in a couple of different ATEMs on-site locations, with Parnell and some of the others. And I want to say thanks for having me back, first off. Oops, wrong button. Um, Today we're going to be focusing on math, and I thought this was a really good one because I find that math is sort of one of those, kind of like the art piece. Those two seem to be overlooked quite a bit, especially when we talk from a technology standpoint. Um, I just feel like there's a lot there that can be done. And even when I see tools and resources, I often don't see them really utilized for the math component. So that's really going to be our focus today. But just to kind of take a little step back and tell you just a little bit about myself, I'm going to minimize this window. So it's not in my screen. I am a certified educator. I was a classroom teacher for 17 years. I've got 20 years total in the public education system, all in the great state of Mississippi. So not too far from you guys, depending on where in the state of Alabama you are. Um, and I have my master's in educational leadership. I've done a stint in gifted education. I spent about the last 8.5 years in gifted grades 2 through 6. But I've kind of done the gamut K-12. My specialty is kind of the K-8 arena. As you can see there, I'm an ambassador for quite a number of things, certified trainer for a couple of different products as well. My email is here. You guys can reach out at any point in time about anything. I'm always more than happy to help and assist you in any way that I can. I don't know if I can hide this little panel. I don't see the little hide button anymore. If you would like a copy of the slides, if you will scan that QR code, and I'll have it again toward the end, just fill out the form and you'll automatically get access to the entire slide deck. And everything within the presentation is linked for you guys. I'm always really big about making it super simple for you to go back after the fact, find any of the resources and links that you need to be able to access anything you might have questions on in case you're one that just doesn't like to reach out and ask questions. But of course, you're always welcome to do that as well. So let's start by talking about motivation because we know that really that is a big part of what we do, right? Motivation and engagement kind of go hand in hand. We have to have the students motivated and we have to have them engaged if we plan to actually do anything or accomplish anything in the classroom. So whether that be your library space, whether that be a math class, whether that be an ELA class, a gifted class, an engineering class, doesn't matter. It's all the same. So that is what fuels them to take action. That's what fuels their enthusiasm and really for them to just want to do and achieve what they're trying to achieve in the classroom, right? Without that, it's really just us sitting up there listening to ourselves or watching ourselves. So it's the force that turns that idea into action and gets them going and really builds that mental, helps them build that mental toughness is a big part of what we need because we know that often getting them to really persist and work through problems is a struggle this day and age with a lot of students because they walk around with one of these all the time and everything is instant gratification, right? So that makes it even harder in a classroom situation for us to keep their attention and keep them wanting to be in the room and engaged. So how do we do this? How do we focus on engaging students and especially from a math perspective? A couple of things to keep in mind is first off, making sure that real world application is a big part of it. Too many times I have to focus on the standard. I have to focus on the standard. Yes, you do have to focus on the standard. We know that we teach and standards are part of what we do. However, when you lose sight of the fact that what you're teaching is bigger than that standard, and that standard was written for a reason, then we lose the whole perspective of what it is we're doing, which also makes it unimportant to the students. Because the first thing a kid is going to tell you, especially if they're at least third grade and above, a lot of them are going to give you the response of, I can Google that, I can find it on YouTube, right? So math concepts need to come to life. They need to incorporate real world aspects. And this really needs a heavy focus on data collection and interacting with the data in real world components. This is what we are continuing to see a huge shortage from as far as a knowledge perspective, both with state testing and just basic. I mean, how many of you have checked out and I can't tell you how many times, the total will be $23.04 and I hand them $100.04 and they look at me like I have five eyeballs and they're like, what do you want me to do with the 4 cents, right? And Lord help me if they've already put it in a computer and it can't tell them what to give you back. They really don't know what to do. So there's just a lot of the data component where we see that there's a fail in that connection between the students and that understanding. And the reason being is not enough real world application. Personalized and collaborative learning are also very important. So thinking about, what is important to the student, what is their interest, and how can you relate what you're doing to an interest that they may have, and really enhancing critical thinking and problem solving. having them work together in a true teamwork fashion. And what I mean by true teamwork is, really working together, not just you're all sitting at a table, all doing the same thing, which is a lot of times what I also see when I'm in classrooms and working with teachers. And then confidence building practice, really reinforcing confidence, getting those wins where they can, and just helping them understand that they can do it, even when it's more complex concepts, because we know that that is going to build more reinforcement of them wanting to do and wanting to do more and take it further. So those are the key things we want to keep in mind. And then motivating instructors from a standpoint of teachers, it's also understanding that you guys need a certain amount to make sure that you stay motivated and that you get the tools that you need to bring into the classroom. So, professional development, helping you make sure you know how to differentiate your instruction, technology tools, which is going to be a big focus of our time today together, and then connecting with the students and their interest and creating a positive math culture. Math is not just for engineers. Math is not just, for these things that they think they're never going to do again when they leave the classroom. So, really keeping in mind that teachers need that support as well, because it is a lot to take in and it is a lot to stay on top of to make sure we're engaging students in the right way. So let's look a little bit at the research before we dive in. As far as I always like to give a background of the importance. Why are we doing what we're doing today? Why are we talking about it? Well, we talked about data and the lack of understanding and what the test scores and things are showing. And research shows that students are highly proficient in using digital tools, but yet only 2% of eighth graders actually demonstrate the ability to analyze and manage information effectively. So they know how to use technology, but we aren't really giving it meaningful purpose for them. They don't know how to do some of the more meaningful things with it, like analyzing data and being able to actually show this in a way that makes sense. And then meanwhile, just 19% can independently gather and organize digital data. So they can find a lot of stuff, but they don't know what to do with it if they do find it, right? So although they may know how to Google or they may know how to use YouTube, they're not really learning how to use it in an effective way. So we want to make sure that we are giving that meaning and purpose. And then let's just look at some data statistics across the country that you might find interesting. Millions of high school students lack access to the basic fundamental courses in math and science that are necessary for success in college and in career readiness. 1 in 5 high schools do not offer Algebra 1 or higher, which I found extremely interesting. And these statistics are actually from 2022. And then 25% of high school students do not have access to calculus. You can see we are well over 1 million students without access to Algebra 1, geometry, Algebra 2, advanced math, or calculus. Over 1.5 million students without access to things like biology, chemistry, and physics, which we know are heavy in the math arena, right? And nearly half of high school students do not have the opportunity to take physics. 1 in 4 high school students do not offer biology or are not offered biology or higher. So you can see a lot of these more advanced courses that really heavily implement data and math, there's just not a lot of exposure to. And you guys being in Alabama, we are actually some of those states, Mississippi, Alabama, a lot in the South is where we're seeing a lot of those gaps in our school systems. So in addition to that, let's talk about the application of why this is important. How does that connect data in real life, right? Students engage in hands-on activities where they need to be collecting, organizing, and analyzing data. They need to be measuring objects. They need to be tracking movements. We talk about GPS, but do we ever really teach students what's involved and how that really works on the back end, right? Conducting surveys or things like programming robots and highlighting how the math components come into play. How does that robot move to those exact locations? There's math involved in that. So we see data in the real world in banking and securities, obviously, but we see it in insurance, right? Aggregating the data. We see it in transportation, education, manufacturing, energy and utilities. We're seeing a lot of it in healthcare, media and entertainment. And guys, I want to add the fact that as we get into this day and age of AI and more technology driven things in the everyday life, math is becoming increasingly more and more important for our students to really be able to grasp its concepts. So, what is the connection between data and AI, data and robotics, data and technology, right? Well, let's talk a little bit about AI in general. So you've got a couple types of AI. We've got explainable data, which is data used to train a model. Then you've got explainable predictions. What features and weights are used for particular predictions? Like what's going into that? Why are we getting this information? How is it predicting? Right? And then explainable algorithms. So, what are individual layers and such that are used for these predictions? So, is it just looking at one data set? No, it's pulling from multiple data sets. And how is it taking that in and looking at all these different parts and pieces that are overlaid to actually come up with the algorithm or the output that that machine is doing or that robot is doing? And I know some of you are hearing this and going, whoa, she's about to get way over my head. I'm not. But I need you to understand that even if this isn't what you teach, these are the foundational skills. And if we aren't giving our students a good grasp of the data and the math, they can never have that opportunity to achieve that higher level because we haven't given them the foundational skills that they need. So, what is the basis of all of this? It's computational thinking. And hopefully, this is something you are heavily focusing on because it's what's tying everything in those core concepts to the algorithms, to eventually the technology and the AI and the more sophisticated practices. So, here is a nice little diagram to help you kind of understand the components of computational thinking and how it all comes together. So, you've got the practices, which is the crane putting everything into place. And then you've got how this actually flushes out. So we've got everything from creating algorithms, working with data, understanding systems, and creating computational models. This is what we see on top. But what are the layers underneath that that we don't necessarily see if we don't make it a point to see? And that is the basic components of computational thinking, which is abstracting the data, decomposing the problem, looking for patterns and what we see as far as that recognition piece, and then the testing and the debugging. So those all build up to being able to actually create an algorithm from scratch, being able to understand and manipulate data, being able to then say, oh, I get all of this, so this is how I can put it into an AI model, and then ultimately being able to output those computer models. So breaking it down even further for you, computational thinking is, like I said, the glue that sort of ties this all together. So what does it mean? We've got problem decomposition. We start with that, breaking down all the complex problems for analysis, taking the parts and pieces and looking at and deciding, okay, this is what I have. Here's all the parts and pieces. Now, what do I recognize? What patterns or trends can I identify? What correlations do I see in the data? And then pulling out, this is the information I need, this is the stuff I don't need, right? Being able to then take that and supply the proper data to the algorithmic design or to the data representations, whatever that format's going to be. And then being able to iteratively test and refine whatever they've created. So being able to make those improvements to whatever solutions and models that they have designed. So that's the reason why, and we've dove into that. So now I want to jump into the meat and potatoes is the physical manipulatives. How do we make math matter in this day and age? How do we help them connect the ideas and integrate that with the knowledge and then do something with it? And how do we get them involved with the real world problem solving? What kind of tools, what options are there? Because we all know that we've been using those green foam squares forever and ever, right? Um, a lot of those older manipulatives that you see here on the screen. This a lot of times just doesn't do it anymore for students because, again, they find it boring. And we know that at least 80% of our job is the engagement, right? But also using technology helps us differentiate a lot easier, a lot less stress on you as the individual educator, and puts a lot more of that weight onto the technology components. So making math matter starts with giving them a story, giving them some meat that they can sort of attach to, giving it reason, and not necessarily a story problem, but it could be, right? Um, but think about this as you are putting together your lesson or your activity, giving it a story that has some meaning for the students, right? Something that might have interest or value. So even thinking about their own interest, what can you bring in? Make the lesson interactive. They need to be doing something. It needs to be as real world as possible. Because again, I go back to students do not understand the why. Why do I need to know this? Why am I going to use this outside of this class? Right? So this is where that big important piece comes in is you have to tell them that. You have to give it the real world relevance. And then introducing physical manipulatives that are going to get their attention. So not only giving them something hands-on, but giving them something that they're going to be interested in actually utilizing. So this is another QR code that you can scan when you get this. These are some lesson activities that I did. These are predominantly for K2. You can expand them a little bit outside of that perspective, but these are some great examples of a sort of shell of a lesson idea that you can utilize for teaching some of those math skills to give you some ideas of ways that you can do very basic concepts like teaching money or teaching ones and tens, things of that nature with some very simplistic devices. So let's look at some tools specifically that you can utilize. And the first one is 3Doodler pens. I see a lot of 3D printing in the classroom. I see the pens, I see 3D printers. What I don't see is a lot of things that could be done with these being executed. I see a lot of surface level stuff, a lot of fun activities, and that's all great and fine, but we really are spending money on tools that can do so much more, and we should be implementing and really reinforcing what these tools can do, right? We can really get into problem solving. We can get into spatial reasoning. We can get into ratios. We can get into XY axis. I mean, there's so many math skills that we can teach, geometry with 3D printing, that the list just goes on and on and on. And obviously, a lot of times it's where do I get the ideas? I don't know where to go for this. Really quickly, before I change slides, I want to show you a couple things. There's a link here for all of the products. Of course, we'd appreciate you going through Maker Maven if there's anything of interest. And then there are several videos, which I'm not going to waste our time on during our session today, but they're typically there to show you a little bit more about the product. So if you're not familiar with it, these are in here as links for you when you go back to the presentation on your own time. I like to make sure, like I said, all the resources are there for you. So the 3D pens are great because they can't burn themselves. So they're excellent for younger students, but also there's a plethora of ideas. So on their platform, you can actually see here, you can sort by math specifically and come up with all sorts of lessons that are specific to math skills. So here's a snowman challenge. You're doing dot doodling with multiplication patterns, and then getting into geometry and symmetry and teaching that from that perspective. So you see, we've kind of run the gamut. This one here is a K2. This is a 3-5. This is a 9-12. Of course, I didn't put a 6-8 in there, but there are lessons in there for that. I see this, whoops. This kind of got cut off here, but that's my grade bands. I need to do some tweaking on that so that that can be seen a little bit better. But these are the different grade bands you can sort by. So you can actually sort on their platform by the subject area, whether you are looking at they're just learning to use the pens, they're more intermediate or advanced. You can search by a particular set of standards if you like. You can search by grade level. So there's a whole lot of options here that you can access to obtain ways to use the 3Doodler and make it really effective for math skills. And then, of course, you have 3D printers. Particularly, we like the Robo E4 printers. There's a regular and a pro model here. These are amazing little printers if you haven't seen them or utilized them, or if you're on the market for one. There's a whole lot of features for the price points on these. And the print quality is great, not to mention they print in about half the time of most of their comparative models on the market. But I wanted to talk about those because even if you already have 3D printers, there is something called My STEM Kits, which is a curriculum for it. It works for their lab disk as well as their 3D printers, which are all made by the same company, which is Mimeo or Boxlight now, who has purchased them out. But I wanted to bring this up because My STEM Kits, if you have 3D printers already, and you're just like, we never use them because we don't know what to do with them. My STEM Kits is a whole curriculum package. You can do the same thing in My STEM Kits where you can sort by subjects, grade, etc. So it is a really great platform and it works with a large majority of the 3D printer models that are already on the market. So if you are interested in that, you want to look at options, reach out and let me know. If you already have 3D printers, let me know what model you have, and I can tell you whether or not the curriculum will be compatible with your current model, which most of them are. And then I just kind of wanted to show you inside of there what some of the options are. So there's data collection with the catapult. We have plant cell scaling. So you're dealing with number systems and scaling and size. You've got topography mapping, testations. You've got turbine design, which there's a whole lot of engineering and geometry and numbers that go into that. And then you've got things that are more basic geometry for younger students, like the liftoff kind of thing, which gets into some more basic measurement and whatnot, but still really great math skills. So there's a lot of lessons in there for that. And then this kind of gives you an idea of how it's laid out and what it looks like. You've got bee bed and breakfast, which is a cute little play on words there. This is a K through 2. You compare solitary and social bees and then create a bee house. So you're dealing with size. It's a whole STEM challenge surrounded by that. And then you can see kind of a picture of one that they did here. That's an idea for you that was built. So again, a super great resource in terms of a way to utilize those 3D printers or those 3D pens, even if you already have them or if you're looking to bring something like that into the classroom. And then the lab disc are another great one. These are super wonderful because literally that is a ton of sensors in that little disc, and it's about yay big. So not bigger than like two of your hands together. So it's not huge. It's portable. You can take them outdoors, so you can do experiments anywhere. And each device has up to somewhere between 10 and 15 sensors, depending on the device. And they're good for different things. So depending on what you're looking for is going to depend on which one of these you want. For instance, if you are looking for something more physics oriented, you're going to want the Lab Disc Physio. The GenSci is going to be more for like your elementary and more basic stuff. And then they have one that is for biochemistry and one for more environmental based things. Notice the battery life is 150 hours. So this is one of the best devices I've seen on the market in terms of making sensors really easy to use, both for teachers and for students, making it portable, and then making it realistic with the battery life and whatnot. So some really great things that you can do inside of there. And again, in that My STEM Kits, there's a ton of lessons already there and available for you. So you see things like heart rate that you can monitor, and such like that, just to give you kind of an idea of the types of lessons that are in there. So students explore how physical activity affects the heart rate. So you see, we're focusing heavily on collecting, recording, and analyzing that data, which is really what we want our students to be doing. Kubo is another great one. Kubo is, again, for your littles. If you have not seen or utilized Kubo, he works with those little tiles. They are their own piece of technology inside of the tiles. So he literally rolls over the tiles and he reads those. And there are different sets. There's actually a whole math set specifically for Kubo, which is really great. So it gives you those numbers, it gives you the math symbols that you need, while also bringing in the coding skills and combining that with algorithmic thinking. And again, there is a platform. There's all sorts of lessons available. Notice he lights up green if it's done correctly. If it's incorrect, he's red. So it gives them very visual, yes, no, I'm doing something right kind of things. And then you can see some of the things that you can do here. This is just a simple display of a math activity and allowing them to practice some of those basic skills in a more fun and engaging type of way. And again, really remember as we're talking, a lot of what we're talking about is how do we get them engaged, right? We're teaching the same skills we've always taught. The problem is the students aren't seeing the relevance because we can't get them engaged enough to get them to that point. So we need to get that engagement, but then we also need to show them that this applies to things that you're going to do in everyday life, right? So being able to pair them with a physical device is a great way to show that real world connection. And then things like gathering that data. And I will tell you guys, if you have never seen kids gather their own data from something like that, it is a game changer the way that they view that. Suddenly they get very territorial over their data and very excited about it because they created it. They don't realize that they have that kind of power. And when they do, it excites them. So it's not that kids don't want to learn. It's a lot of times the methods and the ways that we're going about it just aren't what they need for this generation. So just keep that in mind. On a kit here, if you're one that you're like, I'm not really techie, it's not really my thing, but I like where you're going with this, what's something I can use? ARKit is a great kit, and you can teach a lot of scaling principles. This was actually developed by a true architect who said, I want more of this in the classroom. How do I do this? So sort of think like Lego building, but when they're done, they really have a model that looks very much like a real architect in real life would typically present to a client. So it's really good from that perspective. They have kits for all grade bands. So there's something for everybody at every age range. It brings in those 5 C's. It brings in the real world connection. You can see some of the pieces a little more detailed here. It talks a lot about sustainable design, which if you guys have not heard of the Sustainable Development Goals, I do strongly advise you to gather some information about that. If you would like something, I do have some other presentations I've done on those. If you want to reach out and email me, I'm happy to share that with you and some resources for that. But it really is something that you want to start learning about because that is becoming more and more of a focus in industry. It's also becoming a big focus in education from a grant standpoint. A lot of questions are being asked about that. So really sustainable development goals are something you want to dive into. And then additionally to that, and let me back up really quick. So the sustainable design implementation here with ARKit, they actually have kits that are centered around certain environments. So like coastal living or eco living. And they talk a lot about, what does that mean for sustainability? What are we doing along those lines? So it's really true connection there. And then if you want to take it to a digital component, it does work with SketchUp. So if you're dealing with older students, and you really want to get more technical and start bringing in some of that technology, you can go to the SketchUp digital platform and really integrate the two from a design standpoint. So this shows you a little bit about, their sketching, their drawing. Notice it goes all the way down to age 4 and goes all the way through high school. And like I said, depending on the kit you purchase, there's something for everybody. You're really getting into that design thinking. You're bringing in the 5 C's, which is that communication, that character development, collaboration, critical thinking, and creativity. So we're really hitting all those marks. There's lesson plans included with them. There aren't a ton, but there are lesson plans specific to each kit, which gives you a great way of how to utilize them, what to do with them, and some ideas for a track to put you on. Here's an example of one of them so you kind of can see what comes in it. So challenge one is create a new cube using Arc-It. But make it different than the one you already made. So it's getting an idea of how can I do this differently with the same materials? How does this apply creatively, right, to a structure? So we're seeing cube, we're looking at math skills, right? We're bringing in that geometry, but we're also bringing in that creativity and really getting them critical thinking, but doing it in a way that is utilizing their creativity. And then challenge two is create your own structure using Arc-It, and it doesn't have to be a cube. So we kind of build from the basic skills up. And this is a great way too to really do some career exploration with your students for things that they may not realize really utilize math skills, but also are on that more creative side. Because I do find a lot of times we're short-sighted when it comes to exposure to more creative based jobs. We often have students that don't hear enough about those and don't realize what they are and that they exist. This is another great one if you're thinking, I'm not super techie, but I want some stuff to bring in some great new cool resources to my classroom for math. It's called Clixo. It's one that we recently brought on. I absolutely love these. They are so fun. Kids go bonkers over them. Actually, so do our teachers at pretty much every place that we display them. So they are made out of a PLA grade material, which is stronger than typical plastic. So they're bendable. They are magnetic. And each of the magnetic connections allows for turning, and each turn is a 15-degree turn. So it's very math oriented from that standpoint, but can be used for all sorts of different things. We have people using these for occupational therapy, they're using them for math. I mean, the list goes on and on and on. And then here, I want to just kind of show you some math examples. So we've got everything from angles, right? So I talked about each click and it's a degrees. And so you can teach angles very easily with this. You can do things like measuring. So like the longest snake, right? You can do that a whole lot of ways. Can we measure it physically? Can we count sections? Depending on the age of your students, there's a whole lot of ways to illustrate measurements in those different formats, right? And then measuring with Clixo, there's another one here that gives you some other ways to utilize Clixo for measurement, estimation, comparisons, a lot of those math skills from a data analysis perspective. And then we get into Finch. Finch is great because it is a K-12 robot. It works with microbits, which I am a huge fan of because they're very versatile. They can be used with a whole lot of different resources. If you've heard me speak, you probably know that I like them because of their versatility. They're great. Finch is great for data collection, pattern recognition, and also the algorithmic thinking. The little symbol here that is a plug that comes out. He can actually hold a pin in the middle. He's compatible with some Legos, so you can build on top of him. He has some built-in sensors. And then, of course, the microbit can do a lot just on its own. But then if you look here, there's a lot of different coding options as well. So there's block coding that you can do with Finch blocks. You can program in Java. You can program in Python. You can use it with Snap, which is kind of similar to oh, I'm losing the word right now. Scratch. Sorry. Couldn't think of the platform offhand. Gotta love those old brains. They just give out on us sometimes. But Snap is similar to Scratch and it can also be used in that platform. So really gives you a lot of versatility there from a programming standpoint and what can be done. This is a great example of a math lesson with Finch where they're using block coding. And the students will program Finch to collect distance sensor data, and that is built into the bot. So over the span of 10 seconds, he's going to collect and store data, and then you see the output here that it's giving you. So really, again, getting them down to the basics of understanding I used an algorithm, I'm using a sensor, and I am collecting and then I'm analyzing that data. And then now that I have it, what can I do with it? How can I apply it? Right? In a way that they're going to want to do because they're having fun. It's with a robot. right? So it doesn't feel like work. And then there's the Piper kits. If you haven't seen these, they are another newer addition to the Maker Maven lineup and another one that I truly love. We're bringing in the engineering skills because these are all wooden pieces. So students are actually building these devices. And then once they are built, it works with a breadboard, which you see on top of here. The wires actually plug directly into the breadboard. And before you hear that and start having a coronary, please don't, because they are very, very easy to use. There is a platform that comes with it, and it literally tells you step by step. So it looks like Arduino, but is so much simpler than Arduino, making them very practical to use. You do collect tons and tons of data. I'm sorry, go ahead. Did I have a question? Oh, okay, somebody just didn't mute. That's fine. Sorry, I just wanted to make sure there weren't any questions. And Purnell, if you see anything pop up in the chat or if anybody has questions, I should have said this at the beginning, please don't hesitate to unmute or drop something in the chat. And Purnell, if you see something in the chat, feel free to just interrupt me and ask questions wherever you guys need to. So Piper Make is the platform, and it comes with it, and it is correlated specifically to the device that you are purchasing. So in this case, I'm highlighting the sensor that takes the pulse. So it's a pulse sensor, and there's a whole line of activities that go with it. You see there's quizzes, there's student worksheets. So it really does build out the entire lesson for you. And the kids love that it uses Minecraft looking little characters to sort of do it. So they're very friendly characters. It helps them with the code. Really, it is a plug and play system for you as an educator. There's really no prep, not much for you to do. You set out the parts and pieces and let the students go forth and do. Um, so a nice option there as well. And the heart rate sensor is just one of the options. The base camp is another one that you saw there. It's also another good one, but they have loads of them. There's a ball, there's drone walkers that they have. So, I mean, the list just goes on and on from Piper. There's a lot to explore there. There's even a kit where they can build their own computers. Yeah. So pretty neat. Then we get into drones. And again, this is another one that I've seen a lot of schools adopting drones, which is great. However, what I'm not seeing is them really diving deep into the drones and what they can do with them, right? And really specifically in today's session, talking about that data component. Driving a drone with a remote is all great and wonderful, but really getting into the programming side and into utilizing the sensors that are on the drones and explaining to students, what does this all mean? Are you looking at the physics? Are you looking at the aerodynamics? Are you really looking at, what goes into the fundamentals of flying a drone and what kind of data can it collect and what can you do with that data when it's collected? So a whole lot of things we're really not tapping into from the drones. There's two in particular that we carry. The Co-Drone EDU was designed specific, both of these actually were designed specifically for education. Co-Drone was designed with the idea that this is an inexpensive model that mimics a lot of the key things that you will see when you go into the commercial drones, which is where you have to go to get the certification for drone pilot license. So when they develop the remote and some of the formalities there and how some of the functions work, they had these commercial drones in mind, and how do we work backwards to really get this into the education space in an affordable price, but give students the skill sets that they need. So Co-Drone does a great job of doing that. The one thing it lacks is a camera. The Code Air does have a camera, has most of the same functions that Co-Drone has. The big difference between these two is one, Co-Drone doesn't have a camera. The Code Air does, but also Co-Drone you can program in block coding or Python, and it is approved for the aerial drone competition, whereas Code Air is not approved for the aerial drone competition. It only programs in Python. However, it does have, with Feria Labs, they do have a whole Python level 1 certification prep course, which actually teaches everything students need to know so that when they finish it, they're ready to go take that Python level 1 certification exam. So if you are high school or a CTE teacher that is looking for something in those lines, great product line to take a look at. Definitely reach out and let us know. Whoops. And we can get you some information there. I am so sorry. There we go. So here's an example for a drone lesson with Code Air. You can see that in this space here, I'm showing you an example of the actual platform. This is a video where he's going to go through all the specifics of introducing Code Air. So if you're interested and you want more information, it's there. Within the platform, you see here, you can actually select files, you can upload files, you can edit. So you can take code that's existing, click on it, edit that code, but it literally is going to teach them everything from the parts of the drone to how to program the drone. And you see down in this corner, this is actually a sample of some actual Python coding that would be taking place over to the right-hand side of this within that same screen of their platform. So they do an excellent job of literally taking you from ground zero to the most complicated end of flying your drone and what you can do with the sensors. Oops, sorry. Here's a lesson on Co-Drone's platform. Again, they do an excellent job. This is an intermediate lesson. There's a beginner, intermediate, and advanced lessons. All of their lessons are free. The other thing I will point out is if you go with the Code Air, which is from Varia, there is a subscription for the license to the platform. So there is no subscription for the license for Co-Drone. There is for Code Air. So that's another difference between the two. But you notice here that when we're really looking at drones, I really like this example because you see we're dealing with degrees, right? So you see that those math skills are really coming into play here. Also, when we're talking about things like throttle and pitch and yaw, which are all terms that go with flying drones and how they move, just like you have terminology for boats, you have terminologies for drones. You see here that they're teaching terminology, but they're also teaching the math behind these things that they're wanting them to do. And then we're looking at the fact that there are 7 different programmable sensors that you can utilize to collect different data. And you notice what you're putting in is all in degrees. So students are really starting to understand the degrees matter. And then we've got seconds for how long, what are they doing? And that affects how that drone is going to maneuver. So they get real excited to learn a lot of these math skills because they enjoy flying the drones. And I just don't hear enough conversation around what's going on behind the scenes so that we make sure the students are making those connections to the actual math components. All right, another one that is a great piece of equipment is PyTop. PyTop is a construction kit that's very heavy duty. It's made out of a heavy grade aluminum type of material. Anything from about 3rd or 4th grade all the way through 12th grade, this kit fits for. The biggest hurdle with the younger students, that 3rd, 4th, 5th, is the question of if they're strong enough to push in the little rivets is the hardest part. So you may have to do some assisting them as a teacher if they're having trouble with the strength to do the builds. But as you can see here, all these little colored things in here, and I couldn't get a picture that wasn't quite as grainy, but I wanted to show you there's a lot of components. These are all sensors that you see here. So there's loads of sensors. They also have a platform. It is subscription based, but within the platform, tons and tons of lessons and activities, everything from a full curriculum to I just want a lesson on a specific topic. So you can really sort that either way. Here's some ideas of what you'll find in there. So you see the Robotics 102 gives you a lesson on an emotion detector. And so we're really dealing with how do we program and recognize emotions. Basic game development deals with pixels. What goes into pixels? How does that translate into math skills, right? And then you get the drawbridge in engineering, which really gets into a lot of design features and brings in a lot of math components. And then we get some fun stuff like noise pollution and things like that. How do you measure it? What goes into that, right? Measuring volume and whatnot. So some really nice, fun lessons for students to be able to do. And then I wanted to show you this one because it is one that kind of connects the art world to the math, which I really like. You see a lot of this go on in technology, but a lot of times we don't necessarily understand what's happening. When we look at our computer screens or we look at certain technologies, we see a visual. What we see is like this picture here of Mr. Einstein, right? What we don't realize is that what really is happening is that's being created with a series of coordinates and numbers and information in the background. So students then sort of make those connections to how does this stuff work when you're doing things like implementing filters on social media, right? That they're doing all the time. How does this really work from a perspective of reality and technology and algorithms and all of those back end things that are happening that we want to get them excited about that have a lot to do with math skills? Then we get into one that's what I call a tried and true. Most of you probably know Dash. He's been around a long time. He's kind of a go-to robot for a lot of folks, especially in the elementary scene. He has a lot of real-world connections. One of the things that I really like is there is an entire math section in the platform. And a lot of folks don't realize that Dash has a platform, especially if you've had yours for a while. I had Dash way back before there was a platform and then didn't know it had a platform for a couple of years. So there is a platform, it is a subscription based, but there's a whole section that focuses on math skills. And one of those is classify and organize quadrilaterals. So a great way to bring in math skills if you don't know what to do, you're working with polygons, we want to get that real world architectural connection going on. This is a great way to do it. Data, measurement, geometry, you're sort of bringing in all of those things into this specific lesson. And you can see down in the image here, they're actually working with like blueprints to a house. So again, we're showing there's a reason that you learn this stuff, right? This is how it applies in real world. Here's some additional lessons that you'll find all on their platform. So you can see everything from shapes to multiplication to exponents to 2D figures, and even using Venn diagrams to be able to compare and contrast those 2D figures. So again, notice I'm continuing with that theme of we're collecting data, we're analyzing data, we're implementing data in the real world. How does this really connect all these dots? Then microbits, here's a way that you can use microbits. We talked about microbits earlier when we were talking about Finch, but you actually can just use the microbit itself for loads and loads of projects as well. Here is an example of some microbit lessons that are very basic that introduce some of these concepts related to data. First off, what is data? So they're organizing, they are explaining, they're collecting, they're going into all the things that help them understand what data is. They do a data treasure hunt, so collecting and analyzing things like temperature to identify those patterns and anomalies, gets them really truly analyzing that data and kind of breaking it down, decomposing it like we were talking about before. And then sensor design. So now that we know what these things can do and we understand the data and what a sensor can collect and what all it can do with it, how do we design something that's sensor based, right? What can we do with that? How can we then apply that to solve a problem? And then a more basic tool, but still very important, especially the time of year that we're in, we know is state testing time. Gotta love it, right? State testing. If only we could get rid of all these lovely standardized tests, wouldn't that be nice? But that being said, Owlet is a two-part product. So there's two pieces to it. One's called Glow and one's called Cube. And I'm going to tell my age here, and if you relate, you can tell on yourself, but I'll let you be quiet so you don't have to answer out loud. How many of you remember the old Etch-a-Sketch? If you do, that is the basis for the Glow design. This one's called Glow, and it basically works like an Etch-a-Sketch. So it's got the two knobs that you create pictures and images. This helps teach things like fractions, which is a great tool. And I'm going to tell you, it is night and day what kids really comprehend utilizing this tool. It's also great for things like multiplication is another great one that it teaches. And then you see the modernized version of those green foam cubes that we've been using for decades. This is called Cube. You can actually put two of these towers together and do up to 6 digits. It teaches everything from numbers and place value to money and decimals. Really, really great option. And it's great for this time of year if you're trying to do some of that tutoring in-house. It's also great if you're working with SPED students, you need to collect data. There's ways to do that with devices. I'll show you a little bit what they look like. So this one on the left goes with Cube, which is the little towers. Okay. And so what you see on the screen, the first one, they're asking for them to build a number between 120 and 220, and they're telling them how many cubes they want them to use. So they can get creative, and then it's going to self-check. So again, we talked about earlier that immediate gratification because they're used to carrying these devices around. This is great because it's going to do that without you having to do it as the instructor. Okay. And then we're seeing where they're rounding $1.52 to the nearest 10 cents. And again, they're doing it, placing the cubes in the tower, connecting to a tablet or a device, and it's giving that immediate feedback. These work with loads of different devices, which is great. So that makes them really easy to use. And then over on the right-hand side, these are some examples of what you can do with Glow. Um, Here you see make a fraction that's equivalent to 7/10, and they have to show it, and then make 4 number sentences with a product of 40. So it really gets them thinking about the different ways they can do multiplication and apply that. So that gives you a whole lot of options of ways to bring math in that is very practical. It's skills you have to teach, but in a way that gets students excited and engaged about what you're doing. So incorporating these resources allows you to level up your teaching practices. Okay. And really helps develop those skill sets that we need to be teaching so that our students reach that success. This is that QR code again. If you missed it in the beginning, it's the same QR code, but I put it here again in case you're looking at this and you want a copy of the slides. You can scan that here. I'll give that just a second in case anybody didn't get to do that at the beginning. If you have questions, please unmute. Now is the time. That kind of concludes what I have for us today. This last slide, this is my email. Oh, which is not correct. So I do apologize. Let me correct that really quickly. That should be, I didn't even put in my correct email address. Sorry about that. It should be averwe@makermaven.net. If you need to reach me, you guys can certainly do that. I will also put my contact information in the chat for you guys. So if you have any questions, I'm here. That's really what I have for us today. So I hope you got a lot out of this, and I certainly appreciate you giving up your time today to join me. And I'm putting my cell phone number as well as my email in the chat for you. Pernell, I'll turn it back over to you.
Well, thank you, Alicia. An awesome job as always. We definitely appreciate that. If you do have any questions, we'll stick around for a little while. But at this point, we will conclude the session. Alicia has placed her information in the chat, so please grab that before you jump off. And again, we'll stick around if you have questions or want to ask anything. And remember to join us for our last one next week. Next month. I'm sorry. Pushing us too fast.
And Pernell, you mentioned AETC. I will also be there and doing a couple of presentations, and Maker Maven will have a booth there. So make sure you guys stop by and see us at the event if you're going to attend.
Awesome. That's awesome, Alicia. You got a lot of comments coming in the chat, so you can check those out.
Oh, good. I'm glad I exposed some new things to you guys. That's awesome. And again, like I said, if you have any questions, it doesn't necessarily have to be product questions. If you already have something and you're looking for ways to implement, or you have questions about something you already have, please don't hesitate to reach out to me. I'm happy to help you in any way that I can.